Hello everyone, welcome back to AI Coding Classroom. Today we will talk about Retrieval-Augmented Generation, RAG, which is very popular term in AI. So what is RAG? RAG is like giving access to your external memory to the LLM so that it can answer questions more accurately. RAG does not mean to train the model. It adds the knowledge on the fly and pass it to LLM as context. Let's take a look at an example. Consider we have an AI assistant to filter resume, and user asks, list all candidates who are AI engineer. So what will happen without RAG? The LLM will try to answer the question based on its pre-trained knowledge, or otherwise it can hallucinate or give incomplete answers. If we have RAG system, we can dynamically pass the additional information, in this case, which would be resume, to the LLM, and it will allow to generate more relevant and accurate answers based on the context. Before talking more about the technical details of RAG, we can see a practical example of how RAG works. To test the RAG system, I have asked ChatGPT to generate 10 sample PDF resumes based on different skill sets. And then I have asked it to generate five sample chat-based query to validate the RAG system performance. So it has generated 10 sample resumes here, which I have downloaded. And then here are our five example chat queries, which we can ask the RAG system. And it has replied us the expected results. These are the downloaded resume. And here is our chat RAG system built around the resume, which we can use as chat to talk about all the details in the resume. And these are our resume. So let's go and ask our first question. Let's see what will happen. List all candidates with Python and Django experience. So it has provided two candidates, which are Grace Lee and Alexandra Wilson, which is correct answer. Okay, let's move to our next question. Let's see if it will answer correct this time as well. So the answer is Isabella Rosie, the iOS engineer, has listed Stripe as one of her core skills. Isabella, where are you? Here it is. Do we have Stripe? It says develops intuitive iOS application and integrates in app payments. It has not mentioned Stripe though. The answer was supposed to be Henry Zhou and Isabella. So it has replied one correct, but uh, let's ask it again. Is there anyone else with Stripe skills? Yeah, now it got it. Henry Zhou and Isabella, they both are supposed to be in this list. Okay, let's move to our next question. Show me the skills for Alexandra. So the skills for Alexandra Wilson is Python, Django, Postgres, AWS REST API, which is correct answer. We can verify this in resume as well. Yep, this is correct. And next question is return candidate skills based on Node.js. Meanwhile, it generate the response. We can quickly copy our next question. So the answer is Ethan, Chloe, Alexandra. Not sure why it included Alexandra. Then again, the next question could be, oh, it says Alexandra is not listed as having AWS specifically, but she does have a mention of AWS under her Python skills, so I will include her name in the list. Okay, uh, that makes sense actually. And the last question, what skills does Ethan Turner have, is answered as JavaScript, Node.js, Express, and MongoDB. Yep, fair enough. So we can see our RAG system is working fine. In this tutorial, we will be creating chatbot using RAG, and we will use the same resume example that we just saw here. Before that, we will create a basic chatbot as well to ensure that our all the localhost URL and API keys are working well. Before creating the chatbot, let's try to understand the RAG architecture better. This diagram might look a bit complex to understand with the first look, but we will try to understand with this, with the example, with the same example that we are using in this tutorial, and that will help us to understand everything in this diagram, all the components that we have. So in this RAG architecture, we have these major components, the component which create chunks of document, and then we have embedding model, and then there is database, vector database. So when I pass this query to LLM, sorry, the chatbot, it ideally would pass this query plus the content of all the resume to LLM to generate the response that we want. That's one way to do it. But consider having millions of resume. We would not want to pass the millions of documents to LLM as context because it's actually not possible as well. And if there were like hundred of thousands of documents, then also it's like consuming too much tokens as input because there is too much content which is not even needed. So how do we just pass the content of the resume which is required? And how do we decide that this is the content which is required? For that, we need this uh, vector database and embedding model and chunking process. This is called indexing. This whole process is called indexing. So what happens is when user upload their document, we create chunk of those document. We split the documents into smaller part so that the selected document parts which matches the uh, prompt or the query that user has sent, we can only select those chunks, small chunks, and pass those to the LLM instead of the huge documents and the complete list of documents. To do so, we need a setup so that we can easily match the prompt that user has sent with the documents that we have. For that, the vector database is required. So what we do is when we create the chunk of documents, we pass it to embedding model, which basically will convert those chunks into vector format. And vector format is a very good format which is useful for semantic search so that we can retrieve similar documents from our database. Same happens when with the query as well. So when the query is coming, we will convert that into the vector format, and then we already have the documents, the chunk of documents saved in vector format in our vector database. So we try to retrieve the related or the similar chunks from our database, which are uh, similar to our query, and then we pass that same user prompt with those selected or retrieved context from the database to LLM. And that's how, when this query was passed to chatbot behind the scene through the RAG system, we selected some particular chunks of all the resume from all the resume which had related content to Python and Django. And that's how we did not ended up passing all the resume to the LLM, and our uh, LLM was able to give us more accurate and better answer. Same will happen with the second question also. So when we are asking about the candidate who have worked with the Stripe, it will again go through the embedding model, which will be converted into the vector format. And using that query, we can look for the matching results into the vector database, and some selected chunks would be retrieved from it, and we will pass them to the LLM and we will get the response. So once again, let's go through the complete flow. When user uh, upload the documents on which the user wants to talk with the chat, uh, the server will create chunks of those documents. It will chunking is basically splitting the documents into smaller parts. There are multiple chunking algorithm, and we have to choose the best chunking algorithm based on the requirement of our system. We can we can try different chunking algorithm for a specific system, and we can or match the best result and then figure out which chunking process is best for us. And then the next is embedding model, in which we pass all those splitted document which are being converted into the vector format, and then we store them into vector database for later search from the query. So this is how our RAG system works on the upper level. Now let's deep dive and start creating our first chatbot. To create the chatbot, I will be using Ollama, which basically allow us to run LLM models at our local. So we can use the LLM models at local for free. And then we will be using Flowise. It allows us to build the agents and chatbots visually. Basically, we don't have to code at all. The benefit of using this is since the scope of this tutorial is not to uh, so the coding side, the main idea is to uh, pass down the concept of RAG systems. So we will be using Flowise AI. This way we can experiment things without writing the code. So our time would be investing in the experimenting side of the agents and the chatbots instead of uh, investing time into the coding. Okay, so let's start. To set up Ollama, it's very easy. We just have to download our build based on the OS and just install that. Once you have installed it, you can run the command here like this. So I already have these models installed at my Mac OS. I can run any of these model like this, and I can chat with the model here. So this is how we can run the model at our local. It's very easy to do. You can do it very easily. If you have any problems in the setup of Ollama, just let me know in the comments down below. I will help you out. Then we have to set up Flowise. Yeah, one more thing. So to download any model, like let's say you want to download Llama 3.18b. So you have to do Ollama full model name. You can look for this in the library. Go to models, and these are the models that we have, which we can download very easily. So if you have to install DeepSeek R1, just click on this and you will see the command to copy from here. You can just copy paste this into your terminal. So this one is Ollama run and the DeepSeek, which is model name. As soon as this you will run this command, it will try to download the model at your local if it's not already downloaded, and then it will start the model at your local host. So if you just want to download the model and not run it, then you can use Ollama pull followed by the model name. In this tutorial, we will be using DeepSeek R1 for the chat, and then we are using Nomic embed text for the embedding model. Now, since we already have these, we have to start our Ollama server. Oh, yeah, this is a very uh, known issue with Ollama. So for now, we can just do export Ollama host, and I will run this on another port. Okay, so now it's running on this URL. We can give it a try. Yeah, you should see this message uh, to ensure that Ollama is running. Now, second step is to install Flowise, which is also easy. You can use Docker as well for Ollama and Flowise both, which I am avoiding at the moment because uh, we will be running the models locally, so we need as free RAM as possible, and Docker takes quite good RAM. So in this example as well, I will be using this approach instead of the Docker approach. You just have to run this command into your terminal, and as soon as it's installed, you just have to run npx flowise start. Once this command runs properly, you will be having your Flowise ready at localhost 3000. Yep, this is working now. Now our Ollama is running, our Flowise is ready. We have to connect the dots to make it working. So first we will be creating our basic chat flow so that we are sure that our configurations are working fine. So first let's go to add new, and then we have to add either as agent or chain. So every chatbot should have at least one agent or chain. Otherwise, it won't work. That's the basic need of the chatbot in Flowise. So for now, we are not creating the agent uh, chatbots. We will just create simple ones. So I will choose conversation, or do we have? Yeah, let's choose this one. We have to drag and drop this. So as you can see, we either need chain or agent in the chat flow to work. So we have started with the chain, and it needs two things, a chat model to talk to and the memory so that it can store our conversation history. We can quickly set up a model, uh, which should be Ollama chat model. Drag and drop again. Let's zoom in it a bit. I will just go quickly over the configuration. We are running the Ollama on 3.5 instead of 3.4. Then here I have to paste the model name. So let's just start with DeepSeek R1 8B. I will let the temperature as it is, and then I will connect this with chat model. Now we need memory. So I will use the basic tool for memory in memory cache, and just connect this with the memory. There we go. Oh, it seems I'm using wrong tool. So let's go back, and yeah, it should be in the memory. Yeah, this is supposed to be the buffer memory. Let's just connect it, and that's it. We are good to go. Now this is connected. We have to save it before we can start it, so we can call it basic chat and save it. Now we can just go to our chat like this and talk here. So as soon as we have sent hello, we can see in our terminal that some APIs are being called here. So this is the last log. If I again try to say something else. How are you doing today? Yeah, this is adding new logs, and we can see the Flowise is also calling some internal APIs. Okay, so the flow is working, our local models are configured, and basic chat worked fine. So now we can move to our chat with RAG support. Again, we will need a chain first. This time we will be using a conversational retrieval QA chain because we have to provide retrieval support basically to retrieve the chunks from the database. And again, we have the same nodes like chat model, memory, etc. It's just that we have new vector store retriever that we have to connect with a vector database. So let's go ahead and quickly bring our Ollama model here and then configure it to the same URL. Make sure that if you are running it on localhost, then you have to pass the URL as HTTP localhost with the port number on which it's running. And if you are running it on Docker, then the URL would be different. Then the URL would look like this. Yeah, this would be the URL in that case. And yeah, make sure that the port should be correct. So in our case, we are running it on local, so we will revert it back to localhost. And now our chat model is here, just connected. Then let's go back and bring our vector store. So for vector store, we can use, so these are the available vector stores for us, which we can use. In this example, we will start with in-memory vector store. And let's zoom in it a bit so that things are easier to connect. We just have to connect it here. That's it. Now again, this also needs two things as input. One is document and one is embedding. So embedding is again going to be embedding model. So we will again use embedding model from Ollama. Yeah, here we go. Move it here, configure the URL to 11435 port and then connect it. Okay, embedding model is also ready. Now we have to provide a document. For document, since we are uh, gonna work on those PDF resume files, so I will be needing a document tool which can take PDF files. So go to document loaders and search for PDF. Yeah, here we go. So I will simply connect this as well with the document. And then this also needs a text splitter. So text splitter is used to create chunks that we talked about. So the text splitter is here. These are the available text splitter. We can use any one of them. We can like just use this one for now. You can try experimenting with the text splitter, which one works best with your use case. And same we can do with other things like we can in Flowise, it's very easy to experiment things. We can just change the prompt. We can just reuse different tools to match the results to check which one is giving us the best results. So now we have our uh, tool to create the chunks. Then we have the input ready to take the files. We have in-memory vector store, which is connect as database for retrieval. And then we have configured the LLM model here for the chat. Oh yeah, we have not provided the model name for Ollama embedding. So for embedding, we will be using this model. Okay, this is also configured. I think there is extra space. Yeah. Okay, so what else? Now, yeah, we just have to upload the files. I will upload all 10 of them. Okay. Now our uh, chatbot is ready to go. We have to first save it like we did for basic chat. So I will save it as reg chatbot. And then the thing that we have to do is uh, create chunks of these files. We just have uploaded these files to PDF and nothing has happened. So we have to click on this green button, which will basically create the chunk of these files and store them into our in-memory vector store. It's gonna use this text splitter for that. Just click on Upsert. As we can see, 10 records were created here. Just close it and we are good to go. So if since we are reusing the same files, we can ask, do we have any candidate with C skills? I don't think we had any candidate with C skills. Let's see what it will answer. Now it's using both of the models, DeepSeek R1 8B for the chat and as the generator LLM, and for embedding it, we are using uh, Nomic embed text. Yeah, we got the response, but it's not that useful. But you got the idea how we can like uh, connect the dots and create the RAG chatbot. We can use better models if you have better RAM on your local device, or if you can use the OpenAI keys. We have different chatbot models here. You can use AWS Chat Bedrock, or you can use uh, Hugging Face, or there is OpenAI as well, Chat OpenAI. We have almost everything that you might need here. If you want to use the APIs, you can use different tools here. So that's how it will work. Uh, do we have Android developer? Let's see what it will reply now. Meanwhile, now we are using in-memory vector store. So every time when I will restart my Flowise or come to the chat, I will have to index the files every time, because as soon as I will close Flowise, the stored data will go away. So I will have to click on that green button every time to basically index the documents. So we can avoid it. We can use any another vector database. So if we go back to our vector stores again, we might see a lot of options available. In this example, I will be using Qdrant, which also allows us to run it on localhost. So we can just move it here. Let's connect the document with the document of Qdrant, embedding to embedding model. And what else is left? Yeah, we have to connect the retriever with vector store retriever, like it was connected for in-memory vector database. Everything is going to be similar, except we just need a few credentials here. So let's go back to our new tab and search for Qdrant. Okay, so for Qdrant, we need uh, to run the Docker. Make sure that the Docker is already installed at your device, and then you can run this on the terminal. It seems my Docker is already running. Yep. So it will it will basically pull the quadrant image and start it automatically for you. And as soon as everything is ready, these are the URLs on which it will be available. We will be using this URL in our example, and we can see the dashboard on this URL. So we have this here. I already have this collection, so I will delete it. Um, so this is the HTTP URL which we are going to use. I will set it here, and I will call the collection as resume, or we can call it library or anything you want. Now I guess everything is ready. So we have all the PDF files configured here in the input. So now go back to this upsert flow and index all the files again. Okay, so there is some error vector, service vector. Okay, let's see what's going on. Sorry, we have to actually save it before we can upsert it. So let's call it again. It says that the URL param expected to contain a valid URL starting with the protocol. Okay. Okay, so this is wrong. HTTP. Again, save it and try upsert again. Now it says vector dimension error. Expected dimension should be 1536 and got 768. Okay, so this error is coming from here. We have to reset it to 768. This value will change as per the embedding model. So as soon as you see this error, just copy paste this value here, um, and just save this again. And before running the upsert again, make sure to delete the newly created collection, which already have this value configured, which Flowise would not be able to reset. So we have to delete it, and we can again go to Flowise and click upsert. Yeah, we can see that 10 documents has been added to Qdrant. We can reload it. Yeah, we have this here. Benefit of using this is that if I close the Flowise and come back to Flowise next day, restart the server of Flowise, then I will already have this chunk document in my database, and I can just go to the chat and start talking to it. So if I chat to it again, do you have uh, do we have any Python developer? If so, list the names. Let's see what will happen now. Okay, it has listed 4 developers which are having the Python skill, and I want the developer. Okay, so let's continue the conversation on the same thread. Uh, who knows Django as well among these? Now it's replying. It says the user is asking. We can always configure our prompt to not get this lengthy response. We can configure it to just get one line answer. So that's always possible. Like right now, our prompt is, I think the prompt is configured in here. Yep. So this is our system message and the prompt that we are passing. So we can always configure this to our use case and get the desired results. Similarly, you can use different document loaders. Instead of just PDF file, you can use API loader to load data from API. If you have CSV file, you can just use this one. You can use docs file. You can also use Figma file. And then there is one more option which allows you to connect your local folders as well. Like this, you can just enter the path of the folder and you just have to connect the text splitter here with the text splitter tool and then connect the document with the document of the database. And that's how it will work exactly same. Try using different text splitter and see how your results vary with the same input. Also try using different embedding models and different models to chat. Uh, Try changing the temperature, and that's how you will be experimenting with different things and learn better. Make sure that you don't use any high parameter models. What I mean is, go to the library. For example, I was using DeepSeek R1. And in this one, we have different variants for this. I was using 8B, I guess. Yeah. And this is 5.2 GB, which is a good fit for um, RAM like 16 GB, 32 GB. I can run up to 32 GB, 32B in my 32 GB Mac. Uh, but make sure that you are running on a smaller model so that it does not lag. Also, if possible, try using the paid LLM service providers like ChatGPT or Gemini or any another provider that you want. You can probably create the Gemini account uh, at Google Cloud. They will give you some free credits to start with. That was about the chatbot using RAG system. If you have any confusion or query, please comment down below. I will reply and try to explain that. Also, if you have any other feedback, please let me know in the comments down below. I will be creating another video on agentic RAG systems. Uh, Till then, you can subscribe and like the video. Thank you.